So properties of Z transform. So there are nine properties are there for Z transform: linearity, time shifting, time reversal, scaling, differentiation, convolution, Perceval theorem, initial value theorem, and final value theorem. So linearity. So so this is the equation for linearity, like superposition theorem. So previously we seen about whether it's a linear or non-linear. They have to satisfy that. If it is linear, they have to satisfy superposition principle. So same like the formula also there. So you have to apply then you just apply the formula of Z transform. Then you'll be get the values for linearity and time shifting. Time shifting it's a this time n minus one and Z minus one, where m is positive and r negative integer. So if it is the value, so here also we have to apply like is a transform. So what the value will be get it, then we have n minus 1 value is, so z minus z power minus m x of z. And time reversal concept, so there's another property of z transform. So x of n is equal to x of z. So x of minus n is equal to x of z inverse. So this is the way the time reversal they put it. So the formula for z transform where they have to apply, and finally they got it x of z same value. Even that x of n minus n, that will be changed as x of z minus 1. So that is proved. Then scaling. So scaling x of n is that x capital X of z. So here a power n x of n, so it's infinite value. So x of z power 1a. So this is the value you have to get it. So again the proof is started. So here the value a power n x of n. So if you apply like it's a transform formula, then simplify that, and finally you'll be get the same value for scaling. And differentiation property. So differentiation property. So n x of n is equal to, so minus z d power d z x of z. So this value, left side value, have to prove that this is the right side value. There's a proof differentiation property. So the using that is a transform equation and simplify that, and you will be get the value of this one. And convolution. So convolution is a formula for x of n dot h of n. X of n is input, h of n is equal to impulse response, and finally output value you will be getting x capital X of z, h of z. So this is a formula. So the x of n star h of n, this is a linear convolution sequence. So we have the formula for linear convolution. So this is a summation of k minus infinity to plus infinity x of k h of n minus k. So use that formula, just apply it even as a transform formula. Then finally you'll be get the value is x of z and h of z capital 1. So and y of z is output. And Perceval theorem. So Perceval theorem, they consider two example of sequence x of 1 and x2 of n. So that value they given using complex convolution, we can write the equation like that. So this is the equation. So left hand side I have to prove it as a right hand side. So Perceval theorem, using that is a transform, simplify the equation and you will get it that final equation. And initial value theorem. So this is initial value theorem. So this also you proved by is a transform. So same value will be getting initial value theorem. So there's a limitation also there. And the final value theorem. Final value theorem. So initial value theorem, x of 0 is started, and final value theorem is x of infinity. So limitation of z tends to 1, z minus 1, x of plus z. So that will be how to prove by using z transform, simplify the equation, and finally you will be get the values. Thank you.